the next few slides kind of take us one step further. Now that we hopefully understand what we mean by risk and how we calculate it, then we can say even more about the riskiness, the amounts of risk for our different investments. In this table, we have large company stocks, small company stocks. We also have treasury bills and long-term government bonds, the four that we were looking at a second ago. But the table has even a few more. Average return for each, standard deviation or the amount of risk for each. You might recognize some of these numbers that came up a few minutes ago. And in the last column, we have what is called frequency distribution for each investment. What do the frequency distributions show? Let's pick an example. For example, large company stocks, right? In our table, that's number 1, the first row. Large company stocks. We are essentially saying something like this. Let's say earning a return between 0% and 10% over 1 year. How many times did that occur? What's the frequency of earning that high return? Well, it occurred in 1947, in 1948, in 1956, in 1960, and so on. So we can count how many times it occurred, what the frequency was. And different returns occurred in different years. Some returns were kind of more popular, like the tallest column is for the return between 20% and 30%. That's in 1 year. That's where we have the most years, right, in which it occurred. And so we kind of basically, increase the height of the columns for the return which was more common. And clearly something unusual, like losing more than 40% of your money in 1 year. That only occurred once, in 1931. That's actually part of the financial, like the Great Depression financial crisis in 1930s. Then other unusual returns, for example, very good returns, earning between 50% and 60% in 1 year. That occurred only 2 times. Okay, so that's what the frequency distribution tells us. That's how it's built. Now let's kind of simplify it. First, what does it look like? It looks like what we call the bell curve, right? Kind of smoothly goes up and then goes down. That's what the normal distribution looks like. So normally there's this peak somewhere in the middle, and then what's below the peak and what's above the peak is less common, has a lower occurrence or lower frequency, and it's symmetric on both sides. That's the normal distribution. Okay, so this is an example still on large company stocks. Let's answer a few questions. Question number 1. In the middle, right where we see this, the peak, we have a 0 and then we have 12.1%. What is 12.1%? If you go back a couple of slides, that was nothing but the average return. Average over that time period between 1925 and 2013. Now, next to it, to the right, 32.3%. Above it, it says plus 1 sigma. Sigma is the notation we use for the standard deviation. So it means if you take the average and add 1 standard deviation, you get 32.3%. Does the math add up? Well, let's go back a couple of slides. 12.1 average plus the standard deviation, 20.2, gives us what? 32.3. Right? 32.3. We can instead subtract 1 standard deviation, which would give us negative 8.1%. We can also add or subtract 2 or even 3 standard deviations, and we can even go beyond that. And we would kind of calculate the resulting percent return for those. So that's the answer to question number 1. Question number 2. There are 3 extra numbers under this bell curve: 68%, 95%, 99%. What does, for example, 95% show? It tells us that 95% of the time the return has been between within 2 standard deviations, so between negative 28.3% and up to 52.5%, right? So when we're talking about our 88-year time period, 95% of the time, which is what, I don't know, maybe 86 out of 88 years, something like that, the return fell in this range, and only in a couple of years it was beyond that range, so much lower than negative 28.3% in 1 year, or higher than 52.5% return in 1 year, right? And 68%, for example, shows that 68% of the time, so 2/3 roughly out of our 88 years, the return was within 1 standard deviation. So in this range, between losing 8.1% of the money in 1 year and gaining 32.3% of your money in 1 year, in this range, sort of the greenish, grayish shaded area. Question number 3. We have this pink shaded area on the left and on the right under the curve, kind of where the tails are, right? 2 tails of this distribution. What do those 2 pink shaded areas mean? Well, what do we have for the cutoffs? Minus 2 sigma and plus 2 sigma, right? It means then we also have 95%, right? So 95% of the time we are within this range, and 5% of the time, the remaining 5% of the time, we are outside this range. So 5% of the time the return was below minus 28.3% or above 52.5%. Either below or above these 2 percentages, 5% of the time. That's question number 3. We can also add and say something like, so what does 99% mean? It means 99% of the time the return is within 3 standard deviations, so minus 3 sigma to plus 3 sigma. And the remaining 1% of the time, so 1 in 100 years, right? The return is super high, above 72.7% in 1 year, or super low, losing more than 48.5% of your money in 1 year. And now question number 4. In how many years during 1925 to 2013 was the annual return above 52.5%? So this is 52.5%, right? It corresponds to 95% probability or chance of occurring, right? Or actually occurs, since we're talking about the history, about the past. So annual return above 52.5%. That's this pink shaded area on the right. And so 95% is within 2 sigmas, and what's beyond 2 sigmas on both left and right is the remaining 5%. And because the bell curve is symmetric, each of the pink shaded areas must be the same area. So if you take the 5% that remains and divide by 2, we get 2.5%. So to answer question 4, 2.5% of the time over this 88-year time period, the return was above 52.5%. So what's 2.5% of 88 years? That's, I don't know, 1 or 2 years approximately, right? So that's how often it occurred. And actually, maybe we can go back here. Well, that's where we see, you know, in which years we had it. So these 2 years are our good candidates. Maybe only in one of those the return was above 52.5, and one was just, just barely didn't make the cut. But we can see the answer right here. Okay, so this is the end of the topic of risk in the financial markets.